All right, have you ever talked to your parents about geometry? They probably mentioned proofs at some point. Some people loved them, some people couldn't stand them. But today we are going to start with them. And I tell you what, you will get to be very good at them. I am confident of that. Okay? It's just based on what we did yesterday. Let's go ahead and, we're told that LV is a perpendicular bisector of IE. So bisect means cut in half. That means that I'm using tick marks here just to help me see the diagram. That means that these two are congruent. And of course, we have right angles here and there. So it says, give a convincing argument to support every part of your justification. Well, let's think here. We'll write a paragraph here. Given the above information, we know that what? Angle LVI and angle LVE are right angles, and that right angles are congruent, right? Okay. We also know that IV is congruent to VE, right? Because as bisection of a segment divides it into two congruent segments. Okay. Now, so we're almost there, right? Right now we have a pair of sides, we have a pair of angles, and you realize, well, I'm going to have to do, like if I did ASA, I'd have to have this angle congruent to that angle, but I don't know anything about those. But if I did SAS, LV is obviously congruent to itself, right? Yeah, it is, isn't it? And that would be our third side, and we'd have congruent triangles. So finally, LV is congruent to LV, and this is called the reflexive property. Okay, and that's just if something is congruent to itself. All right, it's pretty obvious. So triangle LIV is congruent to triangle LEV by SAS. So that's a proof right there. And we just did that one in paragraph form. But, some of these paragraphs could be written a little bit differently. And when you first do proofs, it's nice to have a little bit more structure. So most geometry classes, while you could write in paragraph proof all the time, most geometry classes, and we will as well, we will use a two-column proof. Okay? And a two-column proof provides just a little bit more consistency, okay? Consistency. So we're going to write the same thing as a two-column proof. Now, you're going to want to have your reason sheet handy, okay? Your reason sheet that I posted. This reason sheet is going to be a big deal. You're going to use that a lot. It looks intimidating at first, but a lot of it, you will be able to make sense of it pretty quickly. So the first thing that we do is almost all the time is get down our given information. This should really have a top on it. LV is the perpendicular bisector of IE. Notice how I wrote a 1 here. This is step 1. and that's my statement. And then I'm going to have a corresponding, just over to the side, step 1 reason, okay? And how do we know that LV is a perpendicular bisector of IE? Well, simply because it was given to us. We were told that, all right? We were told that. Your statements and reasons that correspond to each other should line up perfectly horizontally all the time, okay? And what I like to do is I like to mark up my diagram right away like I did above. And I want to now, what I say is catch up to my tick marks. You see, we haven't said that these two segments are congruent. We can say that now, but we have to make sure we remember to do that. IV is congruent to VE. In other words, it's a very particular process, very detailed. You gotta get everything down. Now this is where we're going to use our gold sheet. And if you look, why is IV congruent to VE? Take a look at your gold sheet and you see, go down to number 5, okay? 5B. And you're not going to write 5B here, you're going to write it out. It says if a line divides a segment into two, actually, sorry, 5A. If a line bisects a segment, it divides a segment into two congruent segments, okay? Now I know it says a line, but a segment will work as well. If, and you can abbreviate a lot of this stuff, okay? If segment bisects segment, then it divides it into, you know what, I should say, let me just fix this. Divides it into two congruent segments. So we haven't caught up to our tick marks yet. We took care of the segments. Now we got to take care of those angles. Now, it's very tempting to say that these angles are congruent, but we first have to say that angle LVI and angle LVE are right angles, okay? How do we know they're right angles? Again, look at your reason sheet. Normally, I always give it to my students on a gold piece of paper, and I call it the gold sheet. So you're going to hear me reference that a lot. If you go down to number 10 on your gold sheet, what does it say? It says what? If, and again, it says lines, but we can say segments too. If segments perpendicular, then they intersect at right angles. And then after that, we can now say that these two angles are congruent. So it's kind of a drawn out process. And again, what's the reason here? Look at number 4 on your reason sheet. If angles are right angles, then they are congruent, right? Okay. So it took us all that time just to get down the given and to catch up to our tick marks. Of course, the next thing was what? Segment LV, congruent to segment LV. And that is the reflexive property. That's on your reason sheet as well. And finally, you see what we're asked to prove. Triangle LIV is congruent to triangle LEV, and that was by SAS. Now, I'm not going to require this of you, but a lot of teachers do. And it's just kind of a little self-check. So when students say SAS, they want to, as a check, you could make sure, where did I say these 3 congruencies? Well, I said a pair of sides up here in step 2. I said a pair of angles congruent in step 4, and another pair of sides in step 5. So I do have it all there, but you don't have to do that. You can if you want. Okay, segment S is congruent to segment angle S is congruent to angle G. I is the midpoint. So we're given a couple things, and a lot of teachers don't allow you to do this. Oh, actually, let's go ahead and mark this angle S, angle G. I is the midpoint of SG. It does not mean I is the midpoint of TN, at least not initially. So let me mark those. Now to prove, you can probably guess we're going to prove triangle SIT congruent to triangle GIN. So let's fill that in. And I'm not going to worry about this transformation business right now. So let's get our given information down. Most teachers make you do this separately. I'm okay if you combine these into one step. Just saves a little time, and I'm going to do that. Okay. Now again, we want to catch up to our tick marks, right? We mark this congruent. Well, we were told they were congruent, so that's fine. But I is the midpoint of SG. I marked them congruent, and I know it seems obvious, but we have to say that SI is congruent to IG. Now, again, your reason sheet, you go down and you look at number 9. See, if a point is a midpoint, then divide segment into 2 congruent segments. I know it seems obvious, but we have to get that down. Okay? We have to get that down. So we then have 2 things, right? We have a pair of angles, we have a pair of sides, and you realize we need to have an other correspondence. And I'm thinking most of you probably have dealt with this before. This angle here is going to be congruent to that angle there. Lines that intersect, the angles that are across from each other, across from the intersection, they are called vertical angles. And those angles are going to be congruent, right? So we could say that angle SIT is congruent to angle GIN, and that's on your, this is one of the few things that we don't have to use if then. We can just say vertical angles are congruent. You see number 12 on your reason sheet, but I could write if vertical angles, then congruent. But that gives us our third congruency, so this is actually just a 4-step proof. We can now say that triangle SIT is congruent to triangle GIN. That would be by what? Angle ASA. We would have gotten this in steps 1, 2, and 3. Okay. I know it's a lot to take in here in the first day, but it'll come together. Just give yourself a little bit of time. Have that reason sheet handy next to you. Okay. Again, I like to mark things. IL bisects GIR, so that means that's congruent to that. It also says it bisects GLR, so that means that is congruent to that. And you can probably imagine that we're going to prove triangle GIL congruent to triangle RIL. So let's get the given information down. IL bisects angle GIR, and IL bisects angle GLR. Again, we know that because it is given. Okay. Now, what does that bisection tell us? I got to catch up to my tick marks. We can't forget to put this down. So we can say that angle on the right there, angle GIL is congruent to angle RIL. And that's going to be because of bisection, which is, again, reason number 5 on our reason sheet. But, these angles are going to be congruent for the same reason. So I'm okay with you saying that in the same step. So I put a comma after that. And angle GLI is congruent to angle RLI. And this would be what? If, again, look at reason 5. If a segment bisects an angle, actually, is it reason 5 or is it reason 6? Reason 6 is where we're talking about bisecting an angle. If a segment bisects an angle, then it divides it into 2 congruent angles. And because we did, two pairs, they both use the same reason, it logically made sense to do it at the same time. We can go ahead and combine those steps into one. And then, of course, Li is congruent to Li due to the reflexive property. So I think you'll realize pretty quickly that we have another 4-step proof, and that's by ASA. All right. Okay, now this one looks messy. Now, look, to save, anytime you turn anything into me on your homework or on a quiz or test, you can't do this, but in class, just to save time, you see we got 1, 2, 3, we got like these 4 given things, and we're not going to rewrite it. But this is just to save some time in class, okay? All that stuff would go into step 1. A lot of times I'll just start with step 2, honestly, just to save time. But anytime you ever turn anything into me, you'd have to have that step 1 written down and out completely. Now let me go ahead and mark it, AB and AE. Then we have perpendicularity there, we have perpendicularity there, and we have angle C congruent to angle D. Okay. Let's see, what do we have here? I see I wrote, looks like we're going to have, well, catch up to the tick marks. This was stated. This was stated, but this was not stated explicitly, these angles here. So I have to say that angle B, comma, angle E are right angles. And that would be what? If, again, reason 10 on your gold sheet, if lines perpendicular, then they intersect at right angles. And then we can say in the next step that they are congruent. And that's because what? If angles are right angles, then they are congruent. You see how we can abbreviate a lot? I'm still saying the same thing. If angles, right angles, then congruent. And then that allows us to say that triangle AED is congruent to triangle ABC. And that's going to be by what? That's going to be by angle side. We haven't seen that one yet. And I got one more thing to do here. Again, I'm going to go ahead and just start with step 2. Remember, step 1 is all these givens. That's just to save us some time. Notice how we are proving these inner little triangles congruent. Let me go ahead and get my tick marks down. BX is congruent to, okay, this gets a little bit messy here. Watch this. BX and EX. EY is congruent to DY. And then it also says, and I'm not going to mark this. Watch, look at that last given. It says that BX is congruent to DY. So if this is congruent to this, you could really say that all 4 of these are the same, right? So this is this gets a little bit messy. Let's take care of these angles first. Let's go ahead and say the angle CEX, comma, angle CEY are right angles. Again, this is from the gold sheet, reason 10. If lines perpendicular, then intersect at right angles. Let's go ahead and say that they're congruent, right? Angle CEX congruent to angle CEY. If angles right angles, then, whoops, I should have that little arrow symbol in there. Then congruent. Okay. All right, so we caught up to the tick marks here. Now, we want to say that, we know that this is congruent to that. That was told to us. We did that in step 1. This is congruent to that. But now we can, what can we say here? Take a look. We really want these two segments congruent, right? But we said in step 1 that this is congruent to this. We said in step 1 that this is congruent to that. And if these two are congruent, I think it's going to make sense that these two are congruent, right? If segments, these two, are congruent to congruent segments, then they are congruent. That's a little bit confusing, right? This is the transitive property. It's number 11 on your gold sheet, okay? If, whoops, I got to write my statement down. So we want to say XE is congruent to EY. And this would be if segments congruent to congruent segments, then they are congruent. And it goes something along the lines like this. If I have angle 1 and I have angle 2 and I have angle 3, if I'm told that 1's congruent to 2 and I'm told that 2's congruent to 3, then of course 3 and 1 would have to be congruent to each other, right? Because if angles are congruent to the same angle, then they are congruent. Here it's a little bit more complicated because we have if segments are congruent to congruent segments, then they are congruent. So a lot to take in here. This is the easy part. CE congruent to CE. Reflexive. And that allows us to finish up in step 6. And this was by SAS. And if you want to, we did this in steps 3, 4, and 5 with the congruencies. Okay.